Okay, so today we're going to start our journey into the unit circle. We're going to start talking about just some basic angles and how to work with the circle itself. We will be talking about angles. Angle is a union of two rays with a common endpoint. Angles are very often represented by this Greek letter theta. Another common names are alpha and beta over here. We need to talk about an initial side and a terminal side. The initial side is where the angle starts, and the terminal side is where the angle ends. Angle in standard position, everything we're going to be doing is putting an angle in standard position. The vertex is going to be the origin right here. The initial side is going to be the x-axis, the positive x-axis, and we're going to rotate counterclockwise, and that's going to leave us here with the terminal side. So here is our initial side, and over here is our terminal side. Degree measures, angles rotated the initial side in exactly one counterclockwise direction until it coincides with itself as one revolution. Let's just talk about different kind of angles and degrees at first. A 90-degree angle would give us a quarter rotation. So we're just going to be moving over to here. That would put us on the positive side of the y-axis. A straight angle is a half revolution, bringing us over here to the negative side of the x-axis. Positive angles, we rotate counterclockwise from the initial side. Negative angles, we're going to rotate clockwise. So you need to make sure you're looking for the sign in front of that angle. The reference angle, I'm going to be doing a lot of work with this reference angle, is always the smallest angle that you make from the terminal side of an angle with the x-axis, and I'll show you that in just a second. All right, so let's look at a couple of these angles. I want to rotate 30 degrees. You don't have to be exact. You just got to be kind of in the right quadrant, make it look about right. We would start here on the x-axis over here. We're just going to rotate about 30 degrees. It would look something like that. This here is a reference angle. And in this case, the reference angle would equal 30 degrees. I want to rotate 300 degrees. It's positive, so again, we're going to rotate counterclockwise. We're going to be going this way. 300 degrees is going to put us in quadrant 4, starting on the initial side, rotating to about here, and there's our terminal side. Our reference angle at this point is going to be this piece here, and the reference angle at this point would be 60 degrees. We have 60 degrees left before we get to the full rotation. We're talking a negative angle this time, 110 degrees. So we're going to rotate clockwise this time. From here to here would be 90, plus 20 more degrees would put us about over here. This will become, so this is the rotation. This here, over here is our reference angle. And our reference angle in this case is 70 degrees. We went an extra 20. We have 70 degrees before we get to that spot over there. 215 degrees, we're rotating right about to here. It's going to put us right in the middle there of quadrant 2. Our reference angle at this point is going to go down to the terminal side, and our reference angle here would be 45. So I guess we could fill all those in. Then we have something called coterminal angles. This is a circle. There's nothing to stop me from keep going around and around and around and around the axes there. So we're going to just kind of take a look at that for a second. There we go. We need to name one positive and one negative coterminal angle for all the angles in the example here. So if I'm looking at this angle, we have the initial side, we have the terminal side, we have a 30-degree angle. Negative-wise, going in the other direction, it would be negative 330 degrees. And then I just want to name some other angles that would be coterminal. So for example, if I went 30 degrees and then I went another 360 degrees. That would put me at 390 degrees. So that would be the coterminal angles. Looking for the problems above here, the first one we're going to do is the 60 degree. So normally, if I was going to go 300 degrees, so that would normally put me to about here. Then I'm going to go another 360 degrees and stop there. That would be coterminal with 300 degrees. So if I wanted to name another positive angle, it would be the 300 plus another 360. So positively, it would be 660 degrees. If I wanted to name a negative coterminal angle, I can just head in the other direction like here, and that would be negative 60 degrees. For the second angle we were rotating 110 degrees, so that put us to about over here. If you go another, wait, that was negative. Hold on a second. We were rotating the other way. So we went about 110 degrees. If we make another full circle, we wind up back in the same spot. That would put us here. So that'd be negative 110 plus another 360. So that'd be negative 470 degrees as another negative coterminal angle. I could also just measure positively this way, and that would get me a total of 250 degrees. All those angles are coterminal. I could just continue on all these, just going around another 360, another 360, and adding them on. There's an infinite number of coterminal angles for each one. The other angle we did was a negative 215 degrees, which put us about there. Make another trip around the unit circle. So that would be negative 215 plus another 360, giving us negative 575 degrees. If I need a positive angle, we can just rotate positively till we get to there, and that would be a positive 145 degrees. Okay, so that's the bit on coterminal angles. We also have things called quadrangles, which are right here, and those are just angles that end up on the axes. A 90-degree angle would rotate to here, 180 would rotate to here, 270 would rotate here, and again, these are positive, so we're rotating counterclockwise. 360 would bring you back to where you came. Alright, so let's go to the next page here. It says sketch an angle with a given measure, determine the quadrant where the angle's terminal side will lie in. So I'm looking for 135 degrees. It's positive. We rotate counterclockwise, putting us over there. That is quadrant 2. If I'm looking for a negative 120 degree turn, we rotate over here. It's a little bit more than that 90. That winds us up in quadrant 3. Negative 50 degrees. Again, we're rotating clockwise because of the negative. That would leave us in Q4. 460 degrees. Positive, so I'm going to rotate the 360 plus just a little bit more to get me to the 460, leaving us in quadrant number 2. Most of the work that we do will not be in degrees. Most of it will be in radians. We're just talking about what a radian is. It's really just taking the radius here and laying it across the circumference of the circle. So the angle by taking the radius and wrapping it along the edge of the circle. 1 radian is about 180 divided by pi, so that's going to give you about 57.296 degrees. Alright, so 1 revolution, we have 2 radians. 360 degrees is also equal to 2 radians. A lot of times it's easier to use the fact, just kind of divide both of these guys by 2. So we have 180 degrees is equal to pi radians. We need to be able to convert between radian and degrees. You're not to have a calculator in this unit at all. Well, you can do it with the gray calculators, that's fine. So we want to be able to convert. So the conversion rates are just right over here. If you're looking at radians, you're going to take pi over 180 and multiply it by the degrees. That will get that pi in there. Radians are in terms of pi. Degrees, if we want to convert, is 180 over pi times the radians. That will get the pi out of there. So I want to take 240 degrees and change it into radians. I'm going to multiply it by pi over 180, getting those zeros off there, and then reducing, we get 4 pi over 3. The fact that it's negative doesn't change anything. We're going from degrees to radians, so negative 135 times pi over 180. Just kind of reducing that first by c by 5, so I get negative 27 pi over 36, which then simplifies to negative 3 pi over 4. I want to convert each angle in radians to degrees. If I tell you it's in radians and you just have a number like this, the 3.14 has been multiplied in there, so that is still a radian degree. You do not see the little degree symbol on there, also indicating to us that this is radians. We're going to do the opposite. We need to get the pi out of there, so now that pi moves to the denominator. That gets us 900 over pi, and that's about 286.48 degrees. This one we can definitely tell is in radians. We could see the pi that's in there, so it hasn't been multiplied in already. Multiply it by 180 over pi. That helps to get that out of there. Let's see, 6 goes into 180 30 times, and then times 11, we get 330 degrees. Again, the negative doesn't change anything. We just kind of keep it there. We're going to multiply it times 180 over pi. The pi's cancel, like I said. 3 goes into 180 60 times, and we wind up with negative 240 degrees. The last thing we're going to talk about today is arc length. It's represented by S. It's equal to the radius times theta, where theta is in radians. So all these problems work. You need to make sure that your angle is in radians. Okay, so moving kind of down here, I want to find the arc length of a circle of radius 4 meters subtended by a central angle of half a radian. That just means it's making the angle subtended. So S is going to equal r theta. It tells us that the radius is 4. It also tells us that the angle is 1/2 radians, so I know that it is already in radians. That means our arc length is going to be 2 meters. And what I mean by arc length, just to make sure that we're fine, if you're looking at a piece of the circle, I want to know what is the distance that you're traveling from one end to the other of the angle that you're making. Last problem here, find the length of a circle of radius 10 centimeters subtended by a central angle of 120. The first thing I'm going to have to do is change this to radians. And when I do that, I get 2 pi over 3 radians. Now I can use our formula of S is equal to r theta. It tells us that the radius is 10. The angle in radians is 2 pi over 3. And I get S to be 902.88, and that was in centimeters. Alright, so that's the end of our first lesson here, and we will continue on. Thanks for listening.